Okay, so your first major concept today was understanding that sound is a form of energy that moves through vibrating molecules. Second concept was how do we see it or how do we draw it? We diagram it using compression or transverse waves. Compression waves are the ones where they show the molecules squished together, and I'll show you that in a second. And the other is a transverse wave. But now your third major concept today, and we'll play a little more with the oscilloscope in a minute, is is trying to figure out frequency and pitch, what these two words mean, and how are they different or how are they related. So here's a compression wave showing you that energy is passed on to other molecules, and sound is not like a little rubber ducky that's just floating over the top of these molecules. It's a form of energy, and it is passed on. And so this is a compression wave. This is what's really happening in our world when sound is created. There are molecules that are together and some that are apart. And when they are together, we call that a compression or pressed together. And then the places where they are not pressed together is called a rarefaction. This, again, is a compression wave, but it's a lot easier to draw it in a squiggle line. And those of you in person, we will look at it with a slinky. That's a really easy way to understand how this works. But those of you at home, I'm trying my best to explain this to you. So let's think about the fact that when you played with the oscilloscope, you didn't see the molecules squished together. You saw lines, and so that's a transverse wave. All right, so your transverse wave, you should have seen a crest, the top part of the wave. You should have seen some troughs. Those are the lower parts of the wave. Think about a pig's trough. And then a wavelength is the distance between two crests or two wavelengths. This is what you might have seen with your oscilloscope. But now we need to figure out how to make different types of waves. So from music, or thinking about when you hear someone has a deep voice, then those noises, we describe low noises and deep noises as something that sounds like, and then a high-pitched squealing noise, a high noise, or a squealing noise, high pitch. Okay, something more like ee. And so when I said a low noise or a high noise, it had nothing to do with volume. It wasn't how loud or quiet I was. All right, next. So when we're working with low, deep noises on the oscilloscope in just a few minutes, a low, deep noise will look like this on the oscilloscope. This, again, is called a transverse wave. This wave is a low frequency, low pitch noise. Why is it called low frequency? I want you to notice there's a great distance between each of these crests. And so those are a low energy, low frequency wave. And since it's low energy, it sounds like, okay? Just like a low pitch or a low deep voice. When you look at a wave that is called a high frequency wave, you should see there are more frequent crests or frequent troughs, if you would rather talk about it in terms of the number of troughs. These are per second. So when I think about frequency, and I'm asking myself, is this wave or the one before a higher frequency? This one has more frequent waves, so it is high frequency. And in comparison to the one before that sounded like, ooh, this one should sound like, okay? It has nothing to do with volume. Next, let's clarify. Frequency is how often a wave happens per second. This one here, high frequency, it is happening frequently, and so I see more crests and more troughs. This one is a low frequency, so therefore it is a noise that sounds like low pitch, so ooh, and it is happening fewer times per second. It is happening less frequently in comparison to the high frequency. We describe it or measure it in something called hertz. And so it would be per second. And so it would just possibly just be as simple as counting the number of crests per second. You don't have to worry about having to calculate hertz, but look at the comparison here. This one is 15 hertz per second compared to 3 hertz per second. There's a significant difference between the high frequency and low frequency waves. Now, how do they sound? I do need you to identify and be able to describe that a high frequency sound would sound like a squeal. So a high frequency wave has a lot of energy. It happens a lot and it happens more frequently per second. So it would be what we call high pitch. So it sounds like ee! And then the low frequency wave is lower energy. It sounds like a low, deep voice like this, and it happens less frequent per second. So we call that low pitch. Pitch is not volume. Pitch is how high or low a sound or musical note is. Tomorrow, we're going to look at how that compares to volume. So for the next couple of days, I want you to remind yourself the meaning of the word pitch by experimenting with how high you speak. Speak with a high-pitched voice at times, but try to switch up. Whether you're speaking with a high pitch, try and talk louder with a high pitch and quieter with a high pitch. Nothing changes the fact that you're still talking in a squeaky voice. Or if you're talking in a deep, low voice, try to talk louder or quieter. It's a completely separate issue when it comes to volume compared to pitch. All right, so now I want you to go to the virtual oscilloscope and create some low pitch, low frequency waves for yourself. And so if I'm doing it right now, low pitch sounds like, oh, okay. And so I don't see but 2 crests here in this whole second that was measured. I froze it, just 2 crests, but there are 3 troughs. So this wave did not have a lot of energy, so it would be called a low pitch, low frequency wave. But now let's change it up and let's do a high pitch. So, all right, significantly more, there's a higher frequency, there's more waves happening per second. If I count the number of crests or the number of troughs in comparison to the previous wave, this one has a higher frequency. The distance between each wavelength is much shorter. So that one is called a high pitch. So I want you to take a few minutes and practice low pitch and high pitch waves and understand the difference.